Renato will present the next one, modeling cloud and rainfall formation near Fortaleza now. I forgot to say all the other authors. This one, the lead author is Adilson Gandu, Renato, Reinaldo Haas, Costa, and the other one was Renato Gandu, Julia Cohen, and Reinaldo Haas.
My colleague Adilson Gandu asked me to make this talk, and I'm going to show some results that was used with OLAM as well. And here we set the model for the Fortaleza region, centered over here, and here the Atlantic Ocean. So we could get like more or less the location of the radar. This is one of the results for April 11, and the evolution of the precipitation rate as well in millimeters per hour. This is a very interesting case because here we really see the interface between the ocean and land. So we can have like the winds that change like in terms of direction, mainly because of the warming of this region over here. Like we can see that it turns because of here's the time of the day. And sometimes in the evening, we may have some change as well. But if you look at the other case, this 12 April, one interesting feature is that the IPCZ, the intertropical convergence zone, is very close. So it have some effect over this region here. And in the next case, we can see that IPCZ starts playing, like because it approaches the coast. And well, as we can see here, it's a very interesting feature because moisture starts moving from the IPCZ, and the first time that I see this type of line over this region. The model is showing here some very interesting interaction between the IPCZ and land breeze over the region. And we can see like the formation of all these convective systems over this region over here. And I found it very, very interesting, and it seems to be very well shown by the observations as well. This is the other case, 21st April. This case as well, you can see like the wind turning and all the convection do forming over the region here and move from, sometimes it comes from the east. Since the model is a global model, so remote systems can move from here and enter the region from here. Some comparison with observations. This is the precipitation estimated by satellite. And here we see like for this particular case, 11 to 12 April, about, if you look at the scale here, about 60 millimeters. And you can see here the position of the IPCZ that was very, very close to the continent. The estimates of precipitation from the TRIM satellite for this particular case here. You can see here also like precipitation on the order of 25, 30 millimeters over here. And this is the radar region, the location of the radar. And this is very interesting to see also the IPCZ very, very close to the continent. Data from the radar, this particular case. Here, I don't see the time, but it's the same day. But in the previous hour of that, it's the evening time. And the systems, sometimes they move from the southeast over here, like following this type of lines. They follow the winds blowing from here. Sometimes they move from here. And there are different systems that it seems that the interface between the ocean and land also has a strong influence on the type of the system. After some time, if the wind blow from east, we can have like systems that move from here to here. And this is a particular case for 11 April. The systems move from east and enter the state of Ceará and move from here. The model shows very well the approach of these systems from here. And this is the clouds, and this is the precipitation. So we can see that the region that rained the most was over here, because the systems were moving from the east, and so the lines formed like this. It was a very interesting feature, and was very well compared with these observations from the satellite. This is an interesting look, because the model deal with like the microphysics and the cumulus convective parameterization. So we decided to look at separated here the total of precipitation for this case and this case. So this is the sum of both. Here we have like precipitation. The lines here, the contour lines are the topography. So we see that the convection has a strong influence from the topography as well. So in this region, we have the interface with the ocean and topography. So we can like see that the regions that form the most of precipitation are some type of convective precipitation associated with the topography. In both cases, for the cumulus parameterization and for the microphysics parameterization as well. So we can see like the region that it rained the most. Looking at the wind profiles from the radio sounds, this is the height, this is the zonal component. We can see here the negative wind coming from the east. And as you can see, the wind have a strong shear, because it's like from 0 meters per second up to 10 meters per second, just like 500 meters high. And here we don't have wind shear from the other component, south-north component. And this is the case where we have the wind blowing from the east, so the lines are formed like this. It's moving, so the wind is blowing from here. And later on at 12Z, you can see that there is a still strong wind shear here. And there is a turn of the wind from the like +5 up to minus like 8 meters per second. So the systems are organized different ways if you have like the different types of wind shear. Here we are looking at the other case. We are looking at the boundary. So we can see as well the strong wind shear from the zonal component, and not strong shear from the regional components. So this is the case where the line is like over here. And on the right is the model results. And the model shows as well this strong shear here in the boundary layer. So this is the model results. This is the radio sounds. And here as well, the other component from the, as we can see here, the other case. If you look at the strong wind shear as well, the model is doing a similar shear, and there is this turn of the wind direction like here, and the model is able to do like similar pattern. So that's because the model can deal well and represent very well the cloud dynamics of this region. So some of the conclusions we have for now, that the model is able to simulate the small-scale convective systems, precipitation, and model and observation shows several squall lines that near the land-ocean interface and over the ocean. The topography has important influence in the system's development. The squall lines are strongly associated with the wind shear, and the model seems to overestimate the precipitation as observed by satellite data. So, like the previous work, we still are doing this work, is ongoing work, and we still have to do some more intercomparison with observations. Thank you very much.
Thank you. Time for questions. People are still a bit.
I'll be here for 3 days, so we can talk, no problem.
We have two questions here, one. George and then Earl.
That is the approach of the ITCZ. When the ITCZ approaches, with the winds like turns a little bit. Do the want to talk, Jars? Yeah, this is interface. You have this. Sometimes it's difficult to separate because I show here one of the cases that ATCZ was approaching. So the winds start moving towards the region that was raining the most. It was a convergence that, but it has
the trade winds, right?
The trade winds, yeah. Trade winds. Yeah, that's complex. Yeah. In Fortaleza, it rains sometimes in the early morning. That is night. Yeah. Yeah, we are seeing this. Yeah. Yeah, we have seen this as well.
Did you check whether the rains were from deep clouds or shallow clouds?
We did not check yet. That is the next step that Dr. Gandu will check.
Because Fortaleza is one of the places where the hydro estimators, the satellite-derived rainfall, usually doesn't work very well because there's lots of warm rain. So that's one of the objectives of the Chuva project, is to study these cases.
One more question?
Well, thank you. Seems like we are on time, ahead of time. So we'll be able to give Luis all the time he wants. High resolution model, satellite radar, space and time scale cloud organization. The Santa Maria case study.